Welcome to Lifting the Line, a construction contracting podcast.
Welcome everyone to our podcast, Lifting the Line. I have a very special guest with us today. We have Cathy Inglis from Think Brick Concrete Masonry Roof Tile Associations. And it's 3 associations in one. I have Andy here who is from Brickies Network, and he's joining us as well for this special occasion. And of course, I'm Ali. So let's kick us off with a get to know you. How you going, Cathy?
I'm good. How are you?
Yeah, good, thank you. Okay, what can you tell us about the associations?
So Think Brick Australia, Concrete Masonry Association and the Australian Roof Tile Associations are the 3 associations that represent the manufacturing members of those products in Australia. So it encompasses the big manufacturing companies, Brickworks, CSR, Adbri, National Masonry, as well as many little regional manufacturers of bricks and masonry and roof tiles. So we also have associate members that are companies that provide services or products into the manufacturing industry of those. And we've been around for many years, and we're there to mainly advocate and be the credible voice of the industry on all sorts of fronts.
Mm-hmm. You yourself, you've had a very extensive career in brick making and the building association as well. I think you've actually got, is it an OME for your contribution to construction?
I got an AM.
AM. Knew it was
an
something.
Order of Australia medal.
An Order of Australia medal,
Yes.
yeah.
Are you keeping that under your hat?
Yeah.
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 You don't like talking about that.
When I wear
think.
a jacket, I sometimes put the medal on, but it sort of feels a bit pretentious sometimes. So I don't usually. But it was a great honour to be recognised, and it was for services to the building and construction industry. So lots of things I've done over the years of industry work. So I worked for one manufacturing member, Brickworks, for 29 years. Before I came to the associations. So, yes, I'm only 20 years old, but I started very young.
Yeah.
So it's 29 years working there. But over that time, I did a lot of industry stuff outside of the company stuff. So through the Housing Industry Association, government committees, boards, Building Designers Association, various committees and things, which actually is probably more to why for the recognition of my contribution, not just having a job at Brickworks.
Yeah. So at Brickworks, because I'm at Brickies Network and I love Brickwork, what was your role at Brickworks?
So at Brickworks, I started as the technical and mining manager, and I had 3 years in that role. Then I moved into technical and architectural sales. And eventually moved into roles. It was always around the innovation side, technical, but the innovation and research manager. And it was Austral Bricks just to start with when I started that long ago. Yeah. And over the years, Brickworks expanded to acquire other businesses in masonry, in roof tiles, in precast. We had timber, we developed panels. And my role covered research, innovation, but technical and compliance for all the products. So to make sure that every product that got to the market actually was fit for purpose, met all the Australian standards they were supposed to, the requirements of the National Construction Code. So my tech head, I spent a lot of time on National Construction Code, sitting on standards committees to develop the tools and make sure we have rigorous standards that products comply to, and then make sure Brickworks products would meet those standards.
So kind of all the dry stuff that no one really thinks about that goes into the product. They just think about when they purchase the product, oh, yeah, it does the job. But you're actually right at the start all the way to that point.
I bought a brick. A brick's a brick.
Exactly right.
What is there to know about that? Well, there's a lot of things that get tested and declared, and when you use them, they've got to meet certain requirements. But some of the main ones, obviously, things like durability. You want to know if you're using a certain brick, can it be used by the coast or does it need to be used away from the coast? So there's different gradings of bricks. There's different strengths of bricks, whether you're doing load-bearing brickworks like over 4 or 5 stories, you need higher strength bricks than you do if you're building a veneer cladding on a house or a low-rise construction. So there's different properties that all get tested and declared to make sure the bricks are going to do what they need to do, but also last a very long time, which is what bricks do.
Yeah. So in saying that, so when a brick does need to be a certain strength and you get over those different height in the buildings, do all the bricks come up to that, or is there a certain, when you go to the sales store, the salesman actually goes, oh, actually, we can't use that brick in that area because of this reason?
So there are high-strength bricks. So when you measure the strength of a brick, it's not an average value because you don't want an average. It's a standard deviation off the highest value. And the weakest part of a wall is mortar. So it's actually critical that you have higher strength mortar, so an M4 mortar, so one with higher cement to be a stronger mortar. And without getting too technical, in the masonry code, there's a masonry wall strength you need if it's load bearing. And you do that by lining up the strength of your brick, the strength of your mortar, and then it tells you what your wall strength is going to be. So when you put some of the high strength bricks over the years, when we developed a system, we do the testing of the masonry in prism. So you test the bricks laid in mortar, add compressive loads to that. So you will know what the compressive strength of the wall's going to be, not just an individual brick.
Yeah. And so I've been in brickwork as a bricklayer for 35 years. I didn't know this until about 10 years ago. And nearly every other bricklayer I speak to have no idea about this.
Do you know there's different classes of mortar?
Yes, I always knew that, but I didn't know how they correlated to the brick.
To what it means,
to the
to where you can use them?
No idea.
Can I tell you a funny story?
Yes, please.
When I was getting some renovations done, I had COVID and the Brickies had turned up that day and I wanted to make sure my brickwork was perfect because I'm a little bit anal about my brickwork.
I would be too, yeah.
So with the brick, and I'm yelling out the upstairs window at this brickie going, what's the mortar mix you're using? And he's going, what are you talking about? And I said, well, what's your mix? What mortar classification are you using? I don't know what you're talking about. I said, what's in your mortar? Like, what's the ratio of cement to sand to lime? He goes, 1:1:6. And I said, do you know that's called an M3 mortar? And he said, no, never heard of that. I said, how long have you been laying bricks? He goes, 30 years. Oh, okay. I said, out of interest, if you were building this house by the water, by the beach, what mortar would you use? He goes, the same one. I went, oh, no. Okay, so he didn't know that an M3 mortar can't be used in a 1 kilometre of a coastal zone, and he's been laying bricks for 30 years. Maybe he's never built a wall by the beach, I don't know. But it surprised me, the lack of that knowledge. He knows the brickwork is beautiful, absolutely beautiful, no issues with that. But he didn't understand the standards that sit behind getting your bricks and mortar to have that long-term durability performance that you need for a specific project.
So at what point is that at trade school, or is that when you're working as an apprentice, or is that when you are then buying materials and saying or the architect who's speaking into what's required for this particular build when it happens?
So usually in the specification for the project, it will detail what mortar and what bricks have to be there. And if it's in that severe marine environment or high industrial pollution area, they will specify exposure grade bricks and M4 mortars. But the brickie doesn't usually get the specification because the builder has that. But the brickies would have learnt that at TAFE when they were doing their apprenticeship. But that's usually a long time ago for a lot of people and they probably don't know. Yeah. So it's something that...
And the application hasn't happened back then because perhaps it's theoretical.
Yep.
Yeah.
Oh, my goodness.
Yeah. I actually went back through my trade school books just the other day. I got them out. I got a stack of these old, old books. Yeah. They're very old. They're all just photocopy sort of stapled together. But I actually went through them, and I did find it in my fourth module. But that was a long, long time ago, and I've only referred to them really for arches or some of the code that you need for a fireplace for box sizes or things like that. That's really what I've ever gone back to. But in Australia, about 30 years ago, 60 to 65% of bricklayers had done an apprenticeship. Now in Australia, it's about 40%.
Yep, that's correct.
And so there's a lot of reliance that the builder's telling the bricklayer what needs to be done, but there's a lot of assumption by the builder that the bricklayer knows what needs to be done and knows how to read the species and what it actually means to actually say M-class mortar, M4 mortar or M3 mortar. And so there's a lot of disconnect there, which I find a little bit frustrating, but then I didn't know it either. Like I'd forgotten it completely.
Yeah, you're frustrated because it's your trade. I'm alarmed because I'd be a client, I'd be a consumer, And I'd be like asking my builders, are your bricklayers trained and qualified? That's what I would be asking, because otherwise, like, I don't know, how can you guarantee that the person who's going to do the job will have that knowledge?
Yeah,
that
it's
makes
very
me
hard.
nervous.
Yeah.
It does make me nervous. Maybe I'm being over nervous for no reason, but it sounds alarming to me.
Yeah, I think there's some technical disconnect between what's actually supposed to be happening and what's happening there a lot of the time. And it's certainly not intentional. It's certainly not intentional. I know that I speak with so many bricklayers, and it's just like, oh, that's the way we've always done it. And that's the same in any industry,
trade,
any trade. Like, oh, this is the way we do it. And then the bloke that you work for, that's the way they did it. And it just rolls on.
It becomes specialised knowledge, very specialised.
Yeah, absolutely. And I think, like, you only learn those things over a long period of time, but then you kind of have to refresh yourself to retain that information. It's amazing how much you forget over the years.
Well, this is actually what we talk about, getting the next generation through the industry, because they bring the new knowledge and the new skills, and they are fresher. So it's like good to get ages and stages in the industry on the same site.
Yeah, yeah. And there's things that change over the years. So now there's a, you go back to the old, you used lime, you got bagged lime. In the really old days, you'd slake your own lime and then put it in, and that's fabulous. Bagged lime, pretty good. But now there's all these lime substitutes on the market that are being sold. Don't worry about bags and carrying them around. They're heavy. It's bad. WHS. We've got a little bottle that you can take around and chuck in some of that, and it does the same thing. It doesn't do the same thing. It's not lime in a bottle. They're substitutes. Most of them are plasticizers or air entrainers. And does the brickie know what that makes? And it's like, put, say, 200 mils in, and they just put a little bit. I'll put a little bit extra for good measure. And that's actually really bad. That actually deteriorates the strength, the bond strength, the durability of the mortar. But they actually don't know. But they're being sold this by people that sell into the brick industry, and they don't know that what these products are actually doing. They just think, oh, yeah, I can use this instead of lime. That's what they're told, and not actually understand what it's going to mean. So we've just started some research, building all these walls at TAFE in Granville in New South Wales, and got all the apprentices to build the walls trying different lime substitute products. Then we'd measure bond strength, so the hold strength of the mortar to the bricks, and the durability, and then we test into how easy they are to clean. Because some of these products make the brickwork really hard to clean.
Yes.
So it's not just, but what we found was there's a couple of them have nowhere near the bond strength you need to have, which is really bad. So we're actually about to repeat it again next week now, using off-white cement and white sand, because we did it with grey cement. So they're to try and see if there's any difference. But we've got like 4 or 5 products. They're all on the market and being sold.
I was going to say that, so they've been released on the market, but they haven't been fully tested rigorously or anything. But it makes me wonder whether the diverse, like, climates, different climates in our country. You know, we're a big country, so we've got a lot of states, we've got lots of climates. So I guess we've got a lot of different approaches depending on the client. Is that the other climate?
It's not really climate based. So in Australia, like, and I say brickwork is brickwork. Brickwork's a very low risk element in your building.
100%.
And it's a very low risk for something going wrong compared to some other trades, electrical, corrosion of metal, whatever it might be. Brickwork's a fairly low risk thing. So I think that's why it often gets a little bit overlooked. So one of the main things with the weather, and the hotter it gets, is the suction from the water out of the mortar too quickly. But most good brickies, they do the first ones and they work out that they need a bit more water in their mix, or it just goes off too quickly. And what it does, because if the water gets sucked out, it doesn't have time for that chemical reaction to take place, so you don't get the strength of your mortar. So they'd just know that it just goes dry and the bricks will come apart a bit easier. But that's a chemical reaction taking place, and if there's not enough water there, the reaction doesn't take place. So there's certain bricks that are really high absorption. You see brickies might spray a bit of water on before they lay them. But most brickies know that they recognise the different bricks and know what they need to do with changing their mortars depending on the temperature of the day as well.
That's actually something that I really noticed over the years, over say 30 years. When I started my apprenticeship, we really only had 4 products we laid. there was like a concrete brick and a concrete block of maybe a different size. And then there was a brick, either a solid brick or a wire cut brick, but they were the same colour clay all the way through that just had maybe a pattern on the front of it, maybe a speckle, but not really, but it was all the way through. Now we've got all these different products that they might have a black glaze on them or a glaze colour. They're a brown on the inside. They chip a little bit easier. And they're, I don't know if they're not as fired as hard or something like that because they suck up a lot more moisture. Or then there's other ones that are so hard they don't even cure. Like it's unreal. So I reckon that actually got harder as the years went on for a brickie.
Yeah, definitely. And there's so many more types. And I suppose that's part of the joy of bricks, that there are so many different colours, textures, finishes. But that comes from the body, so the grind size that go in. So you're talking some that don't suck the water in. So they'll have a really fine grind, be really smooth finished bricks, but really hard fired. So the higher they're fired, the higher the firing temperature, they have more glassy compound in it. You can't see it, but that's what the ceramic body converts to glassy bodies, vitrification, and that means that they suck less water in. So if you've got a cold day and you've got those really hard-fired bricks with low water absorption, you actually sometimes need to add a additive into the mortar to actually get that bond, or you can only build a few courses up because the bricks, the water won't suck in and the bricks will float.
They start to compress,
and you'll squash your mortar joints because there's not enough water being sucked out.
Yes.
So the reverse of a highly absorption brick that the water sucks out too quickly.
Yeah.
So, but that's I think that's part of the joy. You get all these different variables, but the brickie's got to have the skill to know what mortar you put with what, and make a judgment as you're going to what, do they need a bit of extra water? Do they add an additive in the bondcrete type product to increase the bond strength? So there's some products like some of the stone masonry units that you lay with mortar, they have to have bondcrete in them, or because you don't get any bond because they've virtually got no suction.
Yeah, right.
And the glass bricks are another example. Yeah. You actually put that on the surface of the brick, the bondcrete, and then put bondcrete in the mortar, or you get no bond because glass has no suction at all. But you can still lay them like a brick. You've just got to modify your mortar mix to do that.
Yeah, absolutely. Bricks are one of the most versatile building products I reckon are on the market still. Like that's the thing that a lot of people go, oh, bricks are really rigid. They're actually not. We've been building buildings with lots of beautiful shapes in them for hundreds and hundreds, if not thousands of years around the world. But people think that they're just a brick. And that really frustrates me. Because everyone's like, oh, we're looking for the cheapest. We're looking for something that we can just put on the wall, put a coat of something over the top of, and then that's the exterior wall. But bricks are so much more than that. It does my head in that people don't think of it that once they're laid, they're a finished product. So obviously you need a really good tradesman to install.
You don't want them covered up then, obviously.
You don't want them covered up because they do last for 100 years or more. Yeah.
No, they are. You're right. It's one of the most flexible materials because it's a small unit. So it's really up to the creativity of the architect to do whatever they want with it. And what we've seen in Australia, particularly over the last 10 years, is this escalation of creativity and what they're doing with bricks. So from hit and miss walls, but you barely saw them years ago. Now that's common. That's not even unusual anymore.
Yeah.
Curved walls, arches, they're all standard things. Then you get to really out there stuff like you've got the Frank Gehry building in Sydney, which is the UTS business campus.
That's amazing. I went to that only just 2 months ago. I was walking down the street and I went, what is this? I was fascinated by it.
It's the most amazing building. And that really kicked off as the start of architects going, well, look, they built it. That's so out there. I can do something, maybe not to that scale, but something else. So we now, through our awards program at ThinkBrick, we see the amazing projects that come through with that. And all they're doing is taking that little unit and using it different ways. But because there's so many colours, there's so many different textures, there's different sizes, there's glazed bricks, there's glass bricks, there's long format, beautiful long format slimline bricks. So you've got this huge variety. And then you can mix them together and do all sorts of things. So it's one of those products that has endless possibility. I mean, if you look at sheet products, you just put them up. It's a sheet on a wall and you paint it. That's like, it's flat. It's boring.
Yep.
This has colour, texture, movement. And the other thing, because they're fired clay bricks, they're not exactly the same. So you get this patterning in your wall of the variation of the tones you get from where they sat on the kiln cars when they're fired. So you get this variation, which always gives that sort of nice patterning to a wall. So it just doesn't look like a plain red wall or a plain black wall or whatever it is. It's got this beautiful texture to it. And but also that because they're natural, it's a different feel when you see the wall. Like it's got sort of life to it. I sort of look at it because it's not just a smooth final finish. It's got texture and that sort of movement across the colour and pattern of the wall.
Well, it gives every section of the wall a bit of character. You know, I always think back to solid brick homes because I lived in a solid brick home. I built one for myself, and every section of the wall was a little bit different. You could actually sit back and go, oh, yeah, I remember. Well, because I laid it, I'd go, oh, yeah, I remember laying that. It was a bit of a pain in the because of a twist or something. But then it was some character. But then you go and sit in someone else's house and then they're just a plain plaster wall. Mm-hmm. And I think it almost becomes sterile, you know, which solid brick homes and feature walls inside homes was really common maybe 50 or 60 years ago. And it's coming back now, but I think we had probably a 20 or a 30-year period where there was nothing in a residential house in Australia.
No, but that was also a bit to do with the bricks that were being made. They were very ordinary at that period of time. So
right.
There was a change in the industry about just over 20 years ago with moving into promoting to architects, and also the manufacturers all changed the products they made. And the old guy running the factory wasn't allowed to pick what bricks he made just because they were the cheapest. We had salespeople, and then you eventually got architectural reps and things that drove this process of saying we want different bricks, we want more beautiful bricks, we want different sizes, shapes. We want to do custom bricks as well. The industry now do amazing work, and so many of these projects actually have custom-made products. And down in Victoria, there's Krause Bricks that are out at Stawell.
Yes.
Nearly all their products are custom.
Yeah, I don't think they have a standard range now.
I think they maybe have one or two, but they do custom products for people. And so the architects come up with these wild ideas and go out there and work on the different products with them and say, well, this is what we can do, this is what we can't, and then end up with these beautiful built buildings from that creativity. Because bricks are also one of the materials. You can make anything in a brick, like colours, texture. You can put all sorts of things into bricks, coatings and colours on the surface. So there's so much variety. And when you see these custom brick projects where they've gone to that level of doing something amazing, then you see these most beautiful projects. They're the end result.
Yeah. And they're the visual things that we're looking to have a beautiful building. But one thing bricks have really got going for them as well is they're really great for their thermal mass when you're building a home. Like they don't fluctuate in temperature, the buildings like other buildings. But I know that Think Brick have been doing a lot of research on that over a long period of time, maybe 25 years or more. Can you explain a little bit about what you're doing there?
Yeah. So, it started back in about 2000, the research, and we built 4 buildings up on the campus of Newcastle University. So a cavity brick, an insulated cavity brick, a lightweight building, and a brick veneer building. And we monitored them over a 10-year period from 2003 onwards. And each of those buildings have 105 sensors on them, and the data was taken every 5 minutes for 10 years. So millions and millions of lines of data.
Yep.
But essentially, to be really short, because we don't have 10 hours for me to go through all of that, what the project demonstrated was the benefit of thermal mass and how that controls the internal temperature, keeps it more stable, so you have less demand on heating and cooling that's artificial. So back to old passive solar design principles, where you use the building materials to regulate the temperatures naturally rather than needing artificial heating and cooling to do that. So that's the principle. It's known from years. Before Willis Carrier invented an air conditioner in 1956, before then we actually used buildings. We built buildings that were suited to the climate. Yeah. And you go back in history, how they've built through the Middle East and through deserts, and big, thick walls. Why do they have big, thick walls?
Yeah.
It's thermal mass, and it keeps the buildings cool inside. And but so they're thermal mass, so they act as a little battery. So they store energy and then release it later on. So they absorb it, store it, release it. And even a brick veneer with the bricks on the outside, as the sun hits the external walls, they will heat up, they absorb the energy, they store it for a few hours, then they release it. So as the temperature drops outside, the heat will always move from hot to cold. So it goes back out. It doesn't just keep coming in through your frame and your insulation, it goes back out. So in all these buildings, we have heat flux sensors. So it measures the direction and amount of heat flow, not just temperature.
Yeah, right.
So you can see that the heat flows back outside and doesn't just keep coming into the house. The other thing about bricks being used internally, so yes, they have thermal mass, but they're natural. They have no VOC, so you've got no toxic materials for if you've got people with asthma, health problems, etc. None at all, no VOCs. They also are what's called hygroscopic, which means that they're porous and absorb water. So they absorb sort of the humidity a bit out of the air, but by doing that, it helps adjust the temperature at the same time. It's a very minor, it's very little, but it's very minor. So I relate it to if you go into a cave, you always feel cold, and you can sort of feel cool as you start to go into a cave and you start to feel cooler. But as you stand next to that thermal mass, the coof that's stored in that thermal mass radiates out to and into your body. So it's being absorbed as radiative heat. So whereas temperature, if you have your air conditioner on in a room at one temperature, you don't feel that as much because it's convective heat.
Yeah.
Or cool. But if you stand next to a hot or cold thermal mass surface, your body will feel that more than the air temperature. So it's a really interesting phenomenon. Is it getting a bit too technical?
No, not at all. No, not at all.
So it changes the way you feel when you stand next to something. And in a brick factory, the bricks are fired in kilns up to just over 1,000 degrees. And all kilns are made out of bricks, by the way, as well, because what you're going to keep
Most
firing.
people don't know that.
No, because you've got to build it out of something that's going to be fired every single day. I mean, it does have other, no bricks in the roof. It's got, insulation and lots of other things in the ceiling. But the sides of a kiln are all brick. And when you walk down beside the kiln, best place to be in winter because this amazing radiated heat being radiated out from the brick walls because it's stored in the brick, so it comes out.
Yep.
So it works the same in your house. If you've got internal brick walls, during the day when it's warmer in summer, it absorbs that heat into the walls so you don't feel as hot. And it will slowly release it later on once it cools down. And if you're lucky, you've got ventilation with breezes, you open your windows and it vents it out and it's ready to work again the next day. So that's how it works.
Yeah. And if you haven't lived in a solid brick home, you just don't understand. So the home that I built that I lived in, we put air conditioning in it when we moved out 4 years later because the tenant didn't want to move in without air conditioning in the building. But we had ceiling fans, sliding windows, and we had a wood heater and no other sort of heating in the house. And it was unbelievable. Everyone walking to the house and go, oh, geez, nice and cool in here. Oh, yeah, we just got a ceiling fan going. The big veranda off one side that kept the west sun.
Related to principles of passive solar design, internal thermal mass, some insulation in the right places, some windows for ventilation, preferably cross if you can work out which way your house goes when you build it, but also shading and to stop that summer sun getting in any of your your windows. So I think at Newcastle we measured how much heat comes in through a window, even in the middle of summer. A north-facing window that has no direct sun on it in summer still has about 625 watts of heat coming through just because it's 40 degrees outside. It'll just come through the glass. So you don't realise that that's a heat gain that you then need to put an air conditioner on to cool down if you've got no other means of getting rid of that heat in your house.
It's funny, you can drive around old miners' cottages in country towns and all the windows have little awnings over the top of them. Well, they're there for a reason. Houses, every house that used to get built years and years ago had an eave just to keep the major sun coming off things. Now we've got houses that are just straight up, no eaves, and I drive around and go, they look like a weird a
But
weird
see, they
house.
built those before they had air conditioners, so they had to figure out another way to keep the houses cool.
Yeah.
So they actually designed to it. And even look at the old California bungalows and things. Like they're off the front windows all had a little tiled awning over it.
Yeah.
It's decorative, but it served a purpose at the same time.
Yeah.
And the other thing when you do internal brickwork, so many architects and they'll go and put plasterboard on it because they want a nice finish. I've put the bricks inside, they're going to do really good, and I'm going to put plasterboard. You've just totally made it pointless that you built that wall out of brick because the plasterboard insulates the brick.
Yes.
So if you want that brick to work as thermal mass,
100%.
you've either got to leave it as a feature brick wall or render it or put hard set white plaster on it.
Yep.
3 things. If you put plasterboard, pointless, don't build your brick wall.
I remember years ago, a builder that I worked for, he built this beautiful home. And it was all designed around solar. Even on the northern side, he had a dam so the air would come across and cool it down. There was a big glass light well hallway down the side of it. And we built this solid brick wall straight down the middle. And he goes, it's going to be rendered. No worries. So we actually built it that it was rendered, even though it was beautiful, plumb, level, all the rest of it. We didn't really care too much about how it was going to look perfect. And we didn't point it up. And then he came back to me and goes, I've decided I'm just going to paint that brickwork. And I'm like, why did you do that? We would have done it differently. And he's like, no, it's fine. I'm happy with it. He goes, but even if I put the render on it and paint it, it's going to make a difference to the way it works. So he goes, I wanted to keep it just straight brick instead of doing because if he was going to render it, he was going to use maybe some sort of chemical render, which he said it's going to be slightly not where I want it to be for the thermal mass. Yeah. So it was really interesting. Yeah. I was also in WA a few weeks ago, and a guy said to me over there, he goes, we have to build solid brick homes here because the temperature drops so quickly at night that the house contracts too quickly in a veneer in some places and the walls crack and the paint cracks. And I went, really? I didn't know anything about that, but I don't know. Maybe that's one of the reasons they use solid brick over there too. I don't know.
That's a new one to me.
That's a new one to you?
Yep, never heard that one before.
Never heard. See, I don't know.
Most of the houses in WA are double brick because all the builders and the supervisors are brickies. So they've kept building double brick. So on the East Coast, we used to build double brick until the war, and there was a shortage of building materials. So there needed to be, we didn't have enough bricks. So they put timber frames on the inside and just the bricks on the outside. So they looked like brick homes, but they put timber frames on the inside because there was a shortage of bricks.
Right.
And don't even get me started about Queensland, why they build Queenslanders. That's not because they're the best performing houses. They're the worst performing houses in their climate, and they all think they're the perfect houses. They're not. But that's a whole other story. That's all the building materials they had. That's why they build Queenslanders. So it wasn't driven out of the best performance or anything. It was all about shortages of material and what was available at the time. Then sort of I think builders sort of went, I can probably build this a bit quicker. The timber's probably a bit cheaper than two leaves of brick, bit less mess on site. I don't know what, but it's sort of stuck. Sadly, it's stuck. So that's the change to why it's gone to brick veneer on the East Coast. So most of the builders and supervisors on the East Coast are all carpenters.
Yeah, right.
So it's a big difference. That's the building industry now. In WA, a lot of them have come up as bricklayers, and they've gone through and they're apprentices, bricklayers to be the supervisors, and now they're the builders. So they keep building in brick because they love it. So
I must admit, I do love WA simply because they still put solid walls everywhere and they still pitch roofs on houses over there. Where here, everything's like all timber frame, and that means we'd start putting truss roofs on houses, which is a lot more timber. There's a lot more timber in a truss roof than a pitched roof. You go through it, but it's a lot stronger. It doesn't move as much either. Like there's so much movement in a truss roof compared to a pitched roof. It's just
there's a couple of changes, their regulations about heights and fall from heights that may start to limit them building pitched roofs. It's only the last few weeks this is coming out. So, yeah, they're trying to work a way around it that they can still do pitched roofs because they want to, but they're worried about falls from heights when you're up that high putting a ridge in. Yeah.
Yeah. So from your experience and your so much time in the brick industry, Where do you see we're going now with bricks? What's changed over the last, say, 30 or 40 years, and where do you see brickwork going in Australia?
I think bricks are going to be here for a long time. They're not going anywhere. And I think the industry is adapting to the current challenges in the market. And those challenges are around embodied carbon in the manufacturing process and around circularity. So the use of recycled content into the manufacture of products and the use of them afterwards. Mm-hmm. So on the embodied carbon front, bricks use a lot of energy to fire them. So they have a lot of energy put in up front. But because they last so long, over the life of the product, they're actually better than some other building materials. But at the moment, our regulatory systems are just starting to look at it. They're only going to look at embodied carbon because it's easier and they can't quite get to full life cycle of a building because it's a lot more complex.
Yep.
So when you're comparing products on embodied carbon, bricks are not as good as a lightweight bit of board. But that lightweight bit of board isn't going to be there in 100 years.
Yep.
So they've got to look at that. But the industry to deal with this are now carbonising at a rapid rate of knots across the manufacturing plants. Mm-hmm. So Think Brick last year, we published our first sustainability strategy for the whole industry and decarbonisation roadmap. Mm-hmm. We just held a whole series of workshops with all the manufacturers and we're going to publish the second one by middle of this year with all the new things.
Yep.
We're actually going to try and set some targets, say this is where the industry is going to go, challenge with all the different members because they're all competitors, keep in mind. So we want to have the industry up front because if we want people to think about using bricks, then they can fight over it later who gets the sale. But if we've got to keep bricks being able to be used and not being regulated out of the market because they have upfront high carbon. Yeah. The other thing is circularity. So combining recycled materials into the manufacture of products. And bricks are one of the products. You can nearly shove anything into a brick when you fire it and it makes very little difference to the properties of the bricks, mechanical, physical, whatever.
Yeah, right.
Organic waste, glass, paper, ash, crushed rock, you name it, can all go in there. But there's limits on what you can do because the EPA in each state don't like you to put things in because you don't have a waste license, you've got a manufacturing license. So the industry's working through these. So there's a lot of content goes back into the product, which counts on your circularity measures.
Yeah.
But bricks are also one of the few materials that can be reused with their full structural properties intact. Most other building materials, if you pull it down, you can't go and use it with the exact same properties it has when you bought that product 40, 50 years ago.
Yeah, right. I didn't realise
that. Have you tried to take plasterboard or something? What happens to it? It falls apart.
That's right. Yeah,
we'll put it in landfill. No, but bricks can be full structural properties intact. And there's a few brick recycling yards in Melbourne and Sydney and Brisbane. Mm-hmm. So we just had 2 of the recycling yards in Sydney join Think Brick because they want to be part of the story. And they're the end of that loop that demonstrates that bricks are taken from old buildings, cleaned off, and reused back into another building. And that's a higher level than recycling. So they can be, if they're broken, they get crushed up and used as road base, aggregate, whatever you want. So there's a lot of opportunity to actually close that end of the loop of recycling.
Yep.
And so some people are looking at which one's more important now. And it's the next thing. What are we going to care about? Diverting waste from landfill and using less resources? Mm-hmm. Or do we worry about carbon? And one of the things you mentioned, like the bricks with holes in, the bricks have bigger holes now.
Yeah.
We do that to use less virgin materials, to dematerialise them.
Mm-hmm.
You use less gas to fire them, less fuel to drive them in the truck because you can fit another row of bricks on every pack on the truck because they weigh less.
Yeah.
So these things that are happening, they're not done for no reason. These are all part of this circularity story of what the industry's doing to make sure that we're still going to be building brick buildings in 100 years' time.
Yeah, because I know when I was a construction manager for a building company, I used to hate going on site because I could sit there and go, oh, yeah, all of those brick rubble that's left over from the Brickies, that could just get sent to the recycle yard or go get crushed up into road base, like you said. But we'd use different types of claddings, like say like a cement sheet cladding or even like a fibreboard cladding or a masonite cladding or something like that. They'd cut out the shape for the window and they'd go straight in the skip. And that'd all just go in the bin. And I'd sit there and go, there was even products that were promoted that they were made out of recycled material and that they had a certain footprint. But you lost 20% of it when you were using it because of angles and windows and panel sizes, and it just goes straight in the bin. I was like, the waste side of it is...
The waste is enormous on construction sites, and it's something that's really got to be addressed. And the industry is looking at ways to do it. Like, can you have in the middle, so on a, say, greenfield estate where they're building lots of homes, a certain recycling centre, and your bricks go here, your metal cut-offs go here, your whatever. I don't know, you need the developer to do it, to be able to do it. And if the developer had a big thing full of clean bricks, the brick companies would take it back, not a problem.
Yeah.
Because it all gets reused back into.
Put it back in.
You've got to put crushed bricks back into new bricks. You've got to have 10% of fired bricks go into new bricks because it helps control the shrinkage on firing. And if you don't have enough waste bricks, you've got to get sandstone and put it in. So you don't want to be you need those old fired bricks.
Yeah.
So they have a purpose.
Yeah.
But brick companies, so when I was mining manager a million years ago, I had a few builders I used to use that would bring me all their broken bricks. And the minute they had any waste in their trucks, they got off the list, and the next one, because they were all queued up, because you could only take so much.
Yeah.
But they weren't paying dumping fees. So they loved it. It was a great thing. I got the bricks I needed to make the new bricks, and they got delivery of their stuff for free. So
We used to pay
huge amount.
Crazy.
So to be able to separate your waste and be able to reuse some things, recycle others, but minimise that waste, it saves the builder money. But also one of the things is working out your quantities more accurately, not just I'll just get 5% extra of everything, because you don't need it. The quantities need to be closely worked out so you don't have that. And you go to any construction site, there's this pile at the front of just everything.
Yep.
Yeah.
Looks terrible. It blows around. It's bad for you. But what a waste of resources.
Yep.
So you think about things, if you're trying to reduce the cost and make things more affordable, it's a very little thing, but there's a lot of money thrown away.
Mm-hmm.
And then more money to dispose of it.
Yes.
So, yeah. So we want to do good things with the bricks. So make sure there's ways that the industry can get them back collectively. And you can't go around to every site and pick up a few little pile of bricks or whatever. But there must be a collective way to do this. And a couple of the companies are looking at that now. So, yeah.
I remember when I was running my contracting business, I used to get into supplying all the bricks myself just so I could keep the waste product, because then I'd stockpile it on a pallet and then I'd go and brick up another house that might have been rendered later on. And it was a good money earner for me, because a lot of the time the builder would supply all the bricks but then didn't want to get rid of them. So I'd say, oh, yeah, I'll take those. And 4 or 5 houses later, I'd have enough bricks left over to go and brick up another house. So it was a good thing for me. But then I started thinking, well, what if I could go and get all the bricks from all the other builders that I don't work for? This could be a good thing for me. And I actually approached a few and they were like, oh, no, we don't want to give you anything. We don't want to give you anything. I was like, you can't throw it in the bin. And then I talked to the guy that actually did the site clean, and they were like, oh, yeah, we just went into the Bobcat, straight into the truck, and we took it to landfill anyway. Like, doesn't make any sense. So I think that's somewhere that general building companies, all of them, could really improve, especially with bricks, because it's such an easy one to dispose of.
It's an easy one to do,
That's an easy one.
Some of the other things aren't as easy, but things are going to change. So people need to start looking at ways to reduce the materials, reduce the waste, and then if they've got waste, of what can be recycled or repurposed.
Yep. I know we're a bit pressed for time today, Cathy, so we want to thank you for coming in and having a really good chat with us today. Is there anything that you want to finish on? Is there anything that you don't feel like you've covered off?
I think we've pretty covered a lot of things, but you've met me a few times. You know, I can just talk about bricks for days on end.
Yeah,
so
we both get on a tangent. Yeah.
So the industry is changing and moving forward with new products, evolution to decarbonise, use recycled content. I think it's a really important thing. A lot of people sort of waiting for this shiny new low carbon, zero carbon material. It isn't going to be one in the next 10 years that's commercially available.
Yep.
So we've got materials we've got now, and the industry is changing. People just think bricks, it's an old material, therefore it's not going to be here in the future because it's bricks are the first building material in Australia. There was the first manufacturing industry in Australia when they started making bricks on the shore in Sydney when the convicts came in. James Bloodsworth was one of the convicts that came over in the first fleet. He was a bricklayer by trade, so they appointed him the Sydney bricklayer, and he started getting the convicts together, making bricks and building the first brick buildings for the governor and stuff. So bricklaying is a very important history in Australia as well. But because of that, people go, oh, it's old, it's not going to be here as a future new building material. They're wrong. Brick is going to be.
Brick's here to stay.
Here to stay.
Yeah, rock solid. Awesome. Thanks, Cathy.